All right. A reciprocal. Okay, so this is the beginning to what you're going to do in grade 12. The second page of this is a whole page of notes. Okay. Look, I'm asking you to copy them down. That's a bonus. So a quick start beside everything that's grade 11 only. With reciprocal functions, next year or wherever you do your grade 12, it's going to be variables on top and variables on the bottom, so there'll be some extra steps in there. We're just going to do reciprocal functions today. So if I give you the number 2 and I ask you what's the reciprocal of 2, it should be 1/2, right? So if I give you the function y equals x plus 2, what's the reciprocal function to that? Okay, so we're looking at putting it over 1. So we're doing the reciprocal of something. So this is the first time you guys have seen asymptotes, and they are super interesting. They're an invisible line. You call it a line or a boundary, or I'm not going to write boundary. I don't want me to today. Is it A-R-Y? Yeah. Thanks. I'd like to keep you guys around. So the function is going to approach it, but it's never going to touch it or cross it. Sorry, that's supposed to say touches. I think my big head is a little. So what I'm going to be asking you to do in this one is I'm going to be asking you to graph a function and its reciprocal. Function and its reciprocal. So this function doesn't have any asymptotes. There's nowhere that the graph is going to be like that you can't go. We know that if we were to graph this, the domain would be negative infinity, positive infinity, the range would be negative infinity to positive infinity. Everything's fair game with this one. But all of a sudden, when we have a denominator and the variables in the denominator, what do we have? This is chapter 6. We have something on the bottom that can't be, right? What can the denominator not be? 0. So we have non-permissible values in this, right? Non-permissible value is -2, right? You guys would agree with me? Non-permissible value is -2. So that non-permissible value, what you told me x can't be, that is your asymptote. So when we graph it, so we did non-permissible values in chapter 6. I almost think this is a better lesson to go with 6, but gives you a little bit of breathing room because 6 is pretty terrible. So what it shows up on the graph is like this boundary at x equals -2. So it's an invisible line that we approach, like the graph approaches, but it never ever touches or crosses. That's all true until we get to calculus and we do some derivatives, and then all of a sudden we're crossing asymptotes like it's going over style. Invariant points are points that are the exact same on the original graph and its reciprocal. This thing is reciprocal, this has been annoying. It's not working. Really, it's not working. I'm not sure. Okay. So what does rational mean? Rational means it can be written as a fraction, right? So our rational function is in the form where I have some equation on the top, and there's some expression on the top, some expression on the bottom. P of x and g of x. P of x and g of x are polynomials, and the domain of the rational function consists of all values for x, except for when g of x can equal 0. We know that. The bottom can't equal 0. We know that. All right. So this is your most perfect, your most beautiful reciprocal graph. It's the easiest one. You're going to do this again in grade 12, and all your transformations will be done off this one. That means nothing to you now, but it will in a little while. So we have a vertical asymptote. So vertical, remember vertical is up and down, and it has a horizontal asymptote of y equals 0. So the vertical asymptote is here, and you see that the graph approaches it. Looks like it touches it, but it's hard in graphing software for us not to show the asymptotes. And my graphing software usually doesn't graph the asymptotes for me because technically they are invisible, they don't exist, right? So that's why my graphing software isn't showing you an asymptote. There are no x or y intercepts because these will approach the x-axis but never cross or touch it, and it will approach the y-axis but never cross or touch it because those are asymptotes. And that's not true. The x-intercept isn't there. Okay, so this is what a reciprocal graph will look like. Okay, you guys ready for this? This is exciting. Okay, so here's the deal. What would the regular graph of this be? Y equals x. So some people like to do a table of values because it makes a lot of sense to them. Y equals x is the nice easy graph here. So I'm making out my x's as I go. What's the non-permissible value on this? X can equal 0. And that's exactly where my asymptote is. Okay? So if it's a y equal x graph, x and y are the exact same thing. I'm just going to make up some points. My scale is a little wonky, so I'm going to go 2, 2, 4, 4, 6, 6. So this would be the regular graph. You guys agree with me? Nice diagonal line, easy peasy. But then when you do the reciprocal of it, it looks extremely different. That reciprocal function. So it looks extremely different. So a couple of things I'm going to be able that I'm expecting you to do, kind of like in the absolute graphs. You need to be able to graph a straight line, and you need to be able to graph a line. Okay? Because you're going to do the reciprocal functions of this. All right. So that just kind of gives you the look of it. And we're going to do these. So if I were to do the reciprocal graph, I'm just going to flip some blue. If I were to do the table for the reciprocal graph of this, so x's stay the same. What do I do to the y's? I just reciprocate them, right? Like I just flip them. So at -2, this would be -1/2. This would be, that should be a -1. Because if I take the reciprocal of -1, what is that? 1. It's still -1, right? You guys agree with me? If I flip -1, it's still -1. 0, if I flip 0, so 0 is on the top, 0 goes on the bottom, and that can't happen. So we call that undefined. Right? That's undefined. That's where my asymptote is. 1 reciprocated is 1, and 2 reciprocated is 1/2. Okay, so this here is an asymptote. I've seen some math memes that say kiss my asymptote, and I don't quite understand that because if you understand what an asymptote is, you never touch it. You never cross it, so how are you supposed to kiss it? Anyway, these are my questions I have. math meetings done by people who don't know what they're doing. Okay, so this one, and this one, these are my invariant points because they were the exact same on the original graph. So those are my invariant points. They didn't change. That point will be located on the original orange graph, and it will be located on the blue graph. They'll be the exact same point. So it doesn't change even when I reciprocate it. Invariant. To vary means to change. To be invariant means to never change. Hence, it doesn't change from here to here. Got it? Okay, so that's your basic everyday reciprocal graph. Okay, so now let's go on to the really long and drawn out. Come on. Me too. You slept like a cat yesterday? Like for long periods of time? Nice. Okay, so guidelines for graphing rational functions. These are the exact same notes. These are the exact same notes I give my grade 12. What I just did was I highlighted the things that we're going to do because we have no variables in the numerator. We're only going to have a 1. Okay, ours is always going to be a 1 in grade 11. So find and plot the y-intercept, if any, by evaluating where x is 0. And sometimes there won't be. So then we're going to jump down to 3. We're going to sketch the corresponding asymptotes by solving the denominator. So we're solving for an NPV. So NPV will be our vertical asymptotes. Okay? That makes sense, because those are things that are going to be undefined that can't happen. So it's like an invisible barrier you're drawing that on the graph. 4A. Okay. Do you guys know what degrees mean? The highest exponent in an expression. Okay, so when I talk about degrees, if I have 1 over x plus 2, the degree of the numerator, it has no variable, but I could put a variable in and put the variable to the exponent 0. Right? X to the exponent 0 is what? 1. Anything to the exponent 0 is 1. So the degree of the numerator is 0. And the degree of the denominator is 1 in this case. So if the degree of p of x, so p of x is my numerator, is less than the degree of g of x, then this y equals 0 is always my horizontal asymptote. Don't cross out the horizontal asymptote. And this is going to be the case for grade 11. When we put letters on the numerator in grade 12, all of a sudden you got to memorize these 3 rules. Okay, but that's our next year problem. That's not a big problem. Okay, so how to graph a rational function? Use a table of values, graph a few key points in the shape of the graph. Now, key points would be my invariant points. And what are the only numbers? What are the only numbers that when flipped are exactly the same? And right. So key points would be any x-intercepts, any y-intercepts, any invariant points. Okay, so critical things. You can do a whole table of values if you want, if that makes some people feel comfortable. And again, we're going to use smooth curves to complete the graph between and beyond the vertical asymptotes. I guess enter horizontal asymptotes. Got it? Easy peasy, right? It will make sense, and I just put these guidelines here. You're probably never going to go back and read them, but they're here if you need to refer to them, or if you have no clue what you're doing. Okay, so the first thing we're going to do is we are going to graph the function, and then we're going to graph its reciprocal. Oh, that's big ball. Are we good? Are we ready? How do you want? Why are you touching her? Oh, no. How do you want to graph your linear function? I would graph it by its intercept. I graph it by both of the intercepts. I think that's what I do. So I know that it crosses something around my trees. You guys okay with that? And so let's go by ones here. Let's go to the 3. Okay, I'm all over the place. Okay, so you guys know how to graph by the intercept method? Basically like, yeah, sure. Intercept method just means I'm going to graph by my y-intercept. I'm going to graph my x-intercept. So for my y-intercept, it's going to be -9, right? We're just going to cross the y-axis at -9. For my x-intercept, is it a +3? Yeah. You sure? Okay, look, I'm sick. This is lovely. And I'm going to connect those with a straight line. And because I'm graphing more than one graph on coordinate plane, I have to label this, and I'm going to just label it f of x, because it's been defined in the question. You can write f of x equals 3x minus 9, there's nothing wrong with that, but I have to define it. I do also have to label 2 points on my graph, and I've only graphed 2 points, so those big points are not going to label. Okay? I'm not going to label them because I think this marker is going to jump around, so I don't want to, but you guys should label your 2 points. I'm using the marker as like that. So for the reciprocal function, I like to write it out so I can see it. Okay. What would be my y-intercept? So step 1 on my list was graph my y-intercept. 1, 6. No, 1, 9. Negative 1, 9. There's 2 of us to do that, but we'll get there. Okay, so if I'm going to, so step 1, I'm going to do my y-intercept. Now, some of you are going to feel not comfortable with doing it in pieces. Some of you might prefer to do a table. Okay? But these 2 key points I put on there first. So negative 1, I found. Let's go do it.
Negative 1. Negative 1, 1, 1.
Yes, but I mean, I'm just graphing it, so as close as I can draw it to the y-axis, but it's below. Everybody with me? Why are you drawing onto the curve now? Stress. Yeah. Is it? Yeah. Okay, step 2, non-permissible values. So what are my non-permissible values for this one? Okay, so that's an MPV. If I ask for the equation of the asymptote, what do equations have in them? Equal signs. So the equation of the asymptote is x equals 3. Same thing. Just if I'm asking for the equation, make sure you're giving it to me with an equal sign there. Okay? You will lose the mark for this if you say the equation of the asymptote of x does not equal 3. Because that's not an equation. That's not an equality. Okay, so we're going to draw that in. So this is a vertical asymptote, so up, down, and it's happens at x equals 3. So it's an invisible line, so it doesn't exist, and we draw it in as a dashed line. That's my asymptote. So there's a communications error on your grade 12 exam, and it's all asymptote stuff. So asymptote is drawn as a solid line. If you draw it in as a solid line, that means it's a function. And it's not. It's a boundary, that invisible boundary. The graph crosses are going away from the asymptotes. That's a bad thing. Asymptotes are living but still inside. So if you don't draw your asymptote in, that's a bad thing as well. Okay? So, but the asymptote has to be drawn in with a dashed line, because that shows me that it's a boundary. It doesn't quite exist. Okay? Oh yeah, I don't even know what step 3 was. What was I supposed to do? Graph. I like it. Okay, so here's the thing. Remember when we were graphing the parabolas, we found what our vertex was, and then we picked points to the left and the right of our vertex? Remember that? Yes, when we were doing the table of values. Same sort of thing. Once we find out, and where is our horizontal asymptote? That was, I don't know, I think that would be step 3. It's a constant. It was the one that you didn't have to make the choice. It's always going to be this for this year, because our numerator is always going to be a smaller degree. So I have put my boundaries on my graph. So now I'm going to look at that vertical asymptote. I gotta see. It's going to be loud. Someone on the mic. So I know my vertical asymptote occurs at 3, and that's undefined, right? You guys are so far here? Okay. So now we're going to pick values to the left and to the right of 3. You can pick any points that you want, but we're going to go with those. I love it. Okay. So this is for our reciprocal graph. So if I substitute 1 in for x, what's my answer? 1 negative 6. 1 negative 1 6. There we go. If I put 2 in, so that would be negative a third. If I put 4 in, so this would be a positive 3, a third. And if I put 5 in, positive 1 6. Hey, look at that. What do you notice about that? Same. It's symmetrical, right? Like, pretty. Okay, so now we're going to graph those points. This was a great scale for me to use. Okay, so at 1, I'm at negative 1 6. And at negative 2, I'm at a third. Oof, that's not that great. Oh, yeah, that's negative. No, I'm way over. I'm on the wrong side. Who are you guys? You guys are supposed to be helping me. May use a different color? Is green not working? Are you okay if I use green for asymptotes? That's okay. Okay, so there's 3 points there. Really what I needed to know was that it's going to be in the negative y values. Because I know that my function is going to approach the asymptotes, but never touch or cross them. I'm not done. I haven't grabbed the other side yet. So the other side, they were positive y's. So it was 6 and a third. So you're going to end up with those 2 curved parts. Okay, so I didn't graph a lot of points, but I graphed enough that I know where my Y's are, and they're always going to be touching those. Critical value is that Y-intercept, so you want to make sure that you go through that, okay? And if there's an X-intercept, or there won't be here, you won't have an X-intercept ever. Not in grade 11, in grade 12 you will. Okay, everybody okay with that? Where would my invariant points be? Uh, 4 and 5 and 1 and 2? No, they have to be the exact same from the original graph. So what did we say the Y had to be? 2 and 4. It can't be at 2, and it can't be at 4. What would my invariant? What is the Y value of the invariant points? You guys just told me. What are the things that you can flip? That would be the same. 1 and negative 1, right? So if I want to solve for my invariant points, I think I'm going to go back to my original function because it should be the same no matter which one I put it in. So if I say Y is 1, this is not a nice one. That would be my first invariant point, so it would be 3 1/3 and positive 1. And then I do it again. If I ever asked you specifically what are the invariant points, you don't necessarily have to graph the whole function. You can solve them as long as you know your invariant points occur when Y is positive 1 and when Y is negative 1. Now, we could have solved this in the rational graph as well, and we should get the exact same values. Because they're invariant, they should not change between both the graphs. So I just picked the easier equation to solve. These ones are not nice. I wouldn't graph those in a table of values, I don't think. So in this case, so critical values, when we talk about critical values, that's an A in that, just in case you're wondering. So we're looking for Y-intercepts. X-intercepts. Invariant points. Those would be critical values. We don't have to do all of them. Like in this case, we didn't graph our invariant points. We didn't do that. When I say x-intercept, this won't be on your reciprocal graph, but it will be on your original graph, right? And what you should notice, can I scroll up for a second? What you should notice is if it's the x-intercept on your original graph, that will turn into your vertical asymptote on your reciprocal graph, because your Y value is 0 at that point. So on the original graph, if there's an x-intercept, those are critical values because those will turn into your vertical asymptotes. Okay. I would say this is one of the hardest lessons, and usually we're doing a karate chop for it. All right. Okay, here we go. You guys ready? What? You need this sheet? You need a moment? You need this sheet back? Well, we solved for them. We can just plot those points on the actual graph. No. Critical values or critical points on the graph, these are the things we always expect to be graphed. Like these are the things that make the most sense to graph them, like your y-intercept, you'd always graph your y-intercept. You'd always graph your x-intercept. Like those are critical values that you start to see graph. The invariant points, like not always, but if they're obvious, like in that first graph that we did on page 1, then I would make sure that they're negotiable. But x and y intercepts are kind of non-negotiable. But I will say, on the European provincial exam last year for grade 12, and the y-intercept on logarithm graph, an exponential graph is like, it's like 8 and 2/8 or 2/5 or something like that. Like it was really weird. And so that value we didn't expect to see graphed from students. We just expected the other values that were around it to be graphed correctly. Like, we're looking for you to use the values that make the most sense, but usually your x-intercept and your y-intercept. Invariant points if they're easy. Okay? All right. So now, okay, how many x-intercepts does a parabola have? Sometimes. 1 or none. Okay, so if it has 2 x-intercepts, how many vertical asymptotes will the reciprocal graph have? 2. If it has 1 x-intercept, that would mean the vertex is sitting on the x-axis. How many vertical asymptotes does it have? 1. And if it's not anywhere there's no x-intercepts, how many vertical asymptotes are you going to have? So with that being said, that is going to be a question in your assignment, and it's going to show up either on a quiz or on a test. So don't skip that question if you're unsure how to do it. I always recommend the table of values, like go with the table of values. Okay, so this one is, where is my vertex? Okay, so we have x equals -0, which is not a possibility, over 2 times 1. Oh, I make it up. I don't know if I can do this. So that's going to be 0. If I substitute 0 back into that equation, what do I get? -4. So my vertex is at 0 and -4. So how many, so that's going to be below the x-axis, right? Okay, now, and I'm just graphing this graph, right? I'm just going to start with this one. I always start with the one I feel most comfortable with. You will get marks for graphing a parabola. You'll get a lot of marks, but you'll get some marks. So if you can graph a parabola, you should be good on that yet. So I'm going to do my x-intercepts. That's a difference of squares factoring. Everybody saw that, right? Just nod and smile and say yes. Okay, so I know my vertex is at -4. I know my, what are those called? X-intercepts are at -2 and +2. Okay, so on your test, you're going to have to graph an absolute function and a reciprocal function. Okay, you know what I'm saying here? So you're going to have to know when I graph this, that I'm not flipping a hump or arms or anything like that. But now we'll move on to asymptotes, like 2 different things, right? Like on the chapter 6 test, equations and expressions, we did 2 different things. So let's go by ones. Do I have to graph any more points than that? No. I'm going to make sure that 2 points are labeled, and I'm going to label this graph like alphabetics graph. Okay. You guys ready for the second? And where is my y-intercept? Maybe a quarter. You guys agree with me? Okay, where are my vertical asymptotes? What are your vertical asymptotes or your NPVs? -2 and +2. So I'm going to have two vertical asymptotes. And they must be dashed lines when you draw them in. Okay, so now I have three sections of my graph. Three sections. Left, middle, right. Where's my horizontal asymptote? So y equals 0. So I asked for the equations of the asymptotes. And I will, into mesh. It would be x equals 2, x equals -2, and y equals 0. You need all of them if I ask for what are the equations of the asymptotes. Like I didn't specifically say horizontal and vertical, you gotta give me both. Does that make sense to everybody? I want them to follow along. Those are my MPVs. These ones are my MPVs. This one is standard issue in grade 11. Yeah.
The equations of asymptotes right each equation out.
I'd like to see them each listed out. I know what you mean, like in non-this slide, but in writing those like this ongoing list. I think when there are actually equations of lines, I'd like to see them all separate. And that's a Mescalian thing. You might get to, well, if you're a member of a class, then you'll have to do that. But if you're, I think Thompson makes it too. So it's just because they're equations and not actual points on the line. Okay, all right, we can do this. Okay, so now I'm going to pick points. I call this sign analysis. Some people like sign analysis, some people hate it, some people prefer to do table of values. So I'm going to do, I'll do table of values first, and then I'll tell you what I mean by sign analysis. So I know my first one's at -2, and my second one's at +2. I'm going to pick some values to the left of -2. -3, -4. So let's put those in the equation. I don't even know what my equation is. So 16 minus 4 is 12, thanks. It'd be 1/12, right? Because we're in the reciprocal function. And if I put 3 in there, it would be 1/5. Positive 1/5. So now I'm going to pick values in between -2 and +2 because that's my middle section. I know one already. Right? That's the y-intercept. That's okay there. So if I pick -1 and +1, so it'll be a -3rd. And this would also be a -3rd. And then I'm going to pick values to the right of that last asymptote. So we'll do 3 and 4. And what we should find is that it's symmetrical. All right, with me so far here? Okay, so I'm going to graph those. So at -3, I'm at a positive 1/5. So around there. At -4, I'm at a little bit lower at a positive 1/12. Here, -1 and then -3rd, same on either side. What? Why did they change the color? The dots are on blue. Oh, okay. I'm here for. Did you want them all the same color, or did you want different sections, different colors? No. Fine with that. Okay, so let's look at the left-hand portion there, the far left-hand side. So it's going to approach the asymptotes, but never touch or cross them. So you're always going to have these shapes. It's not going to be anything differing away from them. If you're looking at my function line, it should not vary away from the asymptote. This is going to be like a wide parabola. So if I do this, if I do something like that, that's a half mark deduction because your function is curling away from the asymptote where it should be approaching. So this is incorrect. That's incorrect. So these have to approach the asymptotes and they can't curl away from them. They can run parallel beside them, but they should be approaching the asymptote. If it curls away, there's a half mark deduction. So for those of you who tend to do graphs a little sloppier than others, you gotta get into the mojo of graphing. Okay, so now we're on the far right-hand side. And so at +3, we're at a third at +4. So I'm going to say that most of you feel comfortable with the table of values. Most of you are going to feel the most comfortable with it. The way I learned how to do it was doing sign analysis. And you guys don't have to do this. The table of values is perfectly good, but just make sure you're picking points around your asymptotes. Like that's the most important part. Just like when we're graphing a parabola with our table of values, you want to make sure you have your vertex in there. Just like this, we want to have points in and around our asymptotes. So for sign analysis, it's the exact same thing. Or not. It's actually important. So I'm going to draw a number line. I'm going to do a domain statement essentially. I've got -2, +2. The reason why I picked those two values were why? They're your asymptotes. The same reason why we put them into the table. So give me a value that's less than -2. -4. So luckily we've done that in the table. So I picked -4, I substitute in. My y values are positive. I don't care what they are, I just know that they're positive. Okay, I don't care that it's a 112, I just care that the y values are positive. In between 0, or in between -2 and 2, 0, which was what I was hoping for. The y values are going to be negative. Right? I don't care what it is at that point, I just know my y values will be negative. And then above 2, I'm just going to write down for you. This will be positive y values. So when I go to graph this, y value is positive. In between, y values are negative. Y values are positive. So it gives you the exact same result as your table of values, but I'm looking at it in a positive way. The only downfall is that you have to have your y-intercept graph, that point graphed. So you just got to make sure that your whatever part of the graph that has y-intercept in it goes through it. Does that make sense, everybody? Like I couldn't do, if I put this like this one would be incorrect because my y-intercept should be there. Even if you don't plot that point, I will know where the y-intercept is, and I will be expecting the graph to cross through it. You get what I'm saying? So sign analysis, I don't know what you like better. I think sometimes table of values, because that's what we feel comfortable with. Table of values will never lead you wrong. This is similar to a table of values, but only looking at the positive negatives. So these are my X values, these are my Y values. What's the graph? I like sign analysis because it goes faster, but that's just me. All right.